And that's why I did a few presentations before, 3 months ago, probably some of you remember it. Well, and in those presentations, we've already seen what monads are and how flat map works. And we've seen also a few examples of monads in Scala, like option, list, and either. Well, either is not a monad, but its projections are. So either left and either right are monads in Scala. And now in this presentation, I'd like to show just another example of monad, and this is a parser. Just another example, and we will see how monads help us to design a simple library. So why it's really helpful. Okay, but just a second. Well, but I'd like to remind you about monads right now, maybe for somebody who didn't participate in the sessions before. So, and you know, it's not a math, this session for programmers, so all these definitions are not very strict, actually very loose, but it's good enough for now. Well, so monad is a class, is a generic class, parameterized, M parameterized with the type parameter A, with a method, flat map, and you see the signature. And in addition to that, to make M of A really a monad, we should define a new function. It's not a method. It's kind of, you know, in object-oriented parlance, factory function, unit, which creates an instance of M given an instance of A. Actually, it's simpler than what I'm saying. So you can see it in this example. List is a monad, and we know that list defines flat map in this way, and unit is just a function that creates a list with one element inside. Okay, list is an example of monad. By the way, I'm a little bit cheating because to make M a monad, it's not enough just to declare flat map and unit. We should to make sure that they conform to monadic laws, but I don't want to get into the details right now, and we did it before. Well, I'm a little bit sick today, so I will make it shorter, you know. Well, let's see that we understand what we are saying. Example of flat map of list of integers 1, 2, 3. Flat map function for each element of list creates a new list, and this is the resulting list. Okay, now I'll ask you what will be the result. I'll start from here.
The same.
The same. Okay, and this is an example of monadic law, by the way. Okay, and this, what is the result? I'm asking you. No. You? You? Slava? What's the result of... Okay. Talia?
No, high mic by mic, high mic by mic.
High mic by mic, high mic by mic. Okay. Great, so we understand. Well, okay. In addition to the flat map syntax, there is for comprehension in Scala, kind of syntax sugar, which allows us writing it probably nicer. It's a matter of taste, but anyway, I think it's nicer. So the same examples written with for comprehension. I don't want to desugar this comprehension because we already know what it is. Okay, and now let's put it aside what we've seen right now, and try to think about parser. Well, parser, you know, in a naive way. We are talking actually about how it's called recursive decent parser for LL grammar, but let's put it aside. We are talking about some naive parser. You know, it's a function. If you have a hammer, everything looks like a nail. If you're a functional programmer, everything looks like a function. So let's define it this way. Parser of A, and A is the result type. Maybe it's a function from string to A. Well, it's probably correct, but not convenient, because sometimes parser fails. So it's probably string to option of A. But it's not always convenient, because sometimes parser consumes just some part of string and make a result, okay, and should pass the rest of the string, the unconsumed string, to another parser. Okay, so probably the result will be a pair, not just a result, but a pair of result and the rest of the string. Well, it's not exactly correct, because sometimes parsing rules are ambiguous, and the final definition we will work with looks like that: parser string to a list of pairs, because sometimes we can parse a string in several different ways. And I'll do a little trick, Scala trick now. We won't work with the function, we will work with the wrapper, parser wrapper. Okay, it's just a wrapper over this function. Okay, we will see later why it's convenient for us. Well, and now, okay, we defined the parser type, and now we are ready to define a few trivial parsers, our fundamental basic business blocks to build more complex parsers. Well, this is the parser success, which always succeeds, and this is the parser failure, which always fails. I'll ask you how it works. What? How it works? No? Aviran? Do you know how it works?
It's Scala, it'll take us a while to compile.
Gil, can you explain to everybody how it works?
No, I can't, because I'm having trouble understanding here.
For you, so for people who don't know Scala, what don't you understand?
No, actually, I got it. As I said, it took me a while to understand. Success is a parser that, given any string S, returns the parameter A, the small a. And the string.
Okay, just a second. I'll help you probably. Success. I probably was a little bit wrong. Success is not a parser. It's kind of factory. Yes, it's a function which returns a parser. Okay, and the most interesting thing is here, is the parsing function, and this is just a boilerplate code. I can use some implicit, but I didn't want. I'd want to make it, more clear, more explicit and clear. So I keep this string, and the actual parser is here. So Gil, could you repeat it, please?
Yes.
How it works?
So the parser, the wrap function takes any string and returns whatever you want, the A, the small a, and the string itself. So it's like a null parser that returns whatever you want.
Yeah, some kind of zero parser. Yeah, zero parser.
Fixed, yes.
Okay, so.
But it's not consuming the string.
Yes, it doesn't consume a string, and given an instance of A, it always returns A. A little bit more advanced question, maybe for you, maybe for somebody else. A little more advanced. Okay. Which of those parsers, success and failure, is unit? Unit is a function which returns the success. Okay, great. So this is our unit. Okay, and failure, is even simpler. Okay, so how it works? How does it work?
Just output the string. No, empty list.
Empty list. It always returns. It always yields empty list. Okay. Great. So just to make sure that we understand it, success. Okay, we create this parser. Success with A. What is the result here?
ABC.
A and ABC, and here
no, this is
A1 to 3. Great. Good. Well, now it's a real parser. Simple but real. Parser item. You see the code. Again, the most interesting part is here. Item is a factory function which yields a parser of character. So the character is the result type. And okay, and now I'm asking you how it works. Shai?
Looks like if the string is empty, it will be an empty list.
Okay, so it fails. If string is empty, it fails. Sorry, by the way, I probably didn't say that. If parser returns an empty list, it's a failure. I didn't say that. Okay, so if string is empty, if the input is empty, it fails, and
otherwise it returns the first and the last characters of this.
okay, almost good.
It returns the first character.
Okay, good. So what is the result here? I've created a parser item, and what is the result?
A and BC.
And here? Great. So item consumes just the first character of the input stream, and if string is empty, it fails. Well, excuse me. Okay, let's do it this way. Okay, so we have seen an item parser. And now I want to create a new parser which returns not just the first character, but also the second character of the input string, and fails if the string size is less than 2. And I'd like to make this parser on top of the item parser we have seen before. And in order to do that, I'm not asking you about it, I'll show you how to do that. In order to do that, we should define, and this is, by the way, the whole point of this presentation. This is probably the most interesting and probably most difficult part, so you should be focused, should be in focus. We should define a flat map. So we are slowly making our parser class to be a monad. That's why I defined a parser as a class, not just as a function. And I'm adding a flat map method. Okay, this is the signature, and the signature should look familiar. And this is the most interesting part. Okay, how it works. First of all, flat map returns a new parser of B. Given this parser and this function, it returns a new function, just like flat map of list. This is the most interesting part. So this new parser, actually this new parser, okay, is return. Flat map yields this new parser. This new parser does the following. It runs this function of this original parser first. And what is the return type? What does it yield? List of pairs. Okay. It yields a list of pairs. And now for each element of the list, for each pair, okay, we apply this function. So for each pair, we take the first field, which is the result, apply f to create a new parser b, okay, and apply it to the rest of the string. So it looks like a sequential combination of two parsers. First, we apply to the input string the original parser, get a list of pairs. Now for each pair, for each element of this list, we apply the second parser. Again, we create for each pair a new second parser and apply it to the rest of the string. And it looks like a sequential composition. Okay, so that's the definition of the flat map of parser. And now we'll see how to implement our parser to return the first and the second character of the input string with the flat map. Okay, this is the code. I even formatted it to make it cleaner, so it should be pretty obvious how it works. This function, item 1, 2, returns a new parser which consumes the first and the second character of the input, and it's implemented this way with our item parser and the success parser. Well, now I'd like to, okay, it's fine, but I'd like to code it with for comprehension. And in order to use for comprehension in Scala, I should define not just a flat map, but also a map. By the way, question. Suppose I have a monad and I have a flat map and unit. Can you construct map function given this flat map and unit? Okay, the answer is yes. If you have unit and flat map, you always can construct a map function. So any module is also a functor. But in Scala we have to write it explicitly. And we are writing it in this way. I think it's pretty obvious. So the map function returns parser of b, and this is the interesting part. It applies the first parser and maps, and it gets a list and maps each result in each pair with the function f. Okay, that's simple. And now look. Now I can get this part and replace it with the map invocation, with the map call. And once I do that, I can rewrite my function with for comprehension, which looks, I think, nicer. So this is the function which consumes both the first and the second character of the input. Well, that's how it works. I create it, and now if the input is just one character, it fails, and for those both cases, it returns a pair of the first and the second.
You did a lot of hand waving. I have absolutely no idea how that worked, the flat map. If you're going to explain it in a minute,
okay,
that's great. But
okay.
Go back. No, the map's fine.
The flat map.
No, one forward. Oh, sorry. This one.
This one. Okay.
I may be the only one, but.
Okay. So you want to understand how it works. Okay. So we run the first. So this is the first parser.
Right.
Item returns the first parser. Now we run the flat map. How it works? Okay, what does this flat map return?
Invokes the parser, Invokes the parser, so it runs the parser.
Excuse me. Okay, my question is the following: what does the flat map return? Parser, new parser. Okay, and what does it accept as an argument? What does it receive as an argument? The flat map. Function. Okay. Function of that from the result type to a new parser. Okay. So, and this is the function from the result type to a new parser.
What would A be in this case? What would the type be? What would the type of A be in this case?
Okay, fine. A is a character and B is a pair.
Okay.
Good.
You need to look at the second one first. And then see the result type.
Okay. Do you want me to continue?
Yeah.
Okay. Fine. So okay, all this is a function.
Right.
From A to some parser. Okay, that's fine. So we understand this. Now, look, it's very symmetric. So what does this part of the function do? Okay. So this is a function, I mean the flat map argument, from A to another parser. So this is another parser. Okay, let's see how it works. We are talking just about it. Just about it. Again, this is a new parser. It's an item parser, and we apply to the item a new function. The type of B again is a character, and now we want from type B to create a new parser which returns a pair, and this returns a pair. Success parser always returns, always returns the argument. In this case, we'll give it pair, and it always returns it.
Shouldn't there be another?
Yeah, probably, but okay.
Somehow Scala.
I'm not cheating, but it didn't work. I don't know, but it really works. We can try it. We can try it in REPL. But that's the idea. You know, probably this, it's simpler. Okay, so it's clear. By the way, did you notice that this one is just a map? So flat map, okay, it's just a map. You always can replace this construct with a map. Okay, and if you have a map, you always can replace it with for comprehension, and it looks nicer. It looks nice. Okay. And now I want to just, as an exercise, to create a parser which returns the first and the third character. And now we know how to do that. It's just this. Okay? I don't want to desugar it again, so it's very simple. Now it's very simple. Well, I don't want to demonstrate how it works. You understand that it actually returns the first and the third character of the input string. And now let's build a little more parsers. Okay. Let's look at this parser. This function sat creates a new parser, okay, which uses this predicate. Can you tell me how it works? What does it do? The name of the parser is obscure, I know.
The predicate. The first character has to satisfy the predicate.
Okay, so if it takes the first character, if it satisfies the predicate, it returns it, and otherwise it fails. So it just returns the first character if it satisfies the predicate. Great. Very simple. And now we can build with, now it's easy. By the way, it's an easy part. Now you can build many parsers, different parsers, just with this set. And again, I wanted to show, I want you to notice that we use this flat map again, okay, to combine, to compose basic fundamental parsers. So we have only 3 fundamental basic parsers: item, success, and failure, and we can combine them with a flat map and make many different parsers. That's what I think is nice here. So okay, so this parser, what does it do? Neta, what does it do? Slava? English? Sorry. Okay. So this is the parser which returns the first character if it satisfies the predicate. So how it works? This is the predicate. So if the first character is C, it returns it, and if otherwise it fails. Okay, very simple. Lower digit. Okay, let's. Okay. Anyway, what does it do?
Checks if the character is lowercase.
Okay, it checks if it's lowercase and it's a lowercase, it returns. If the first character is a lowercase, it returns it, otherwise it fails. If the first character is digit, it returns it, otherwise it fails. Okay, simple. Good. And that's how it works. I create a new parser this way, and that's how it works. Okay. Obvious. Okay, now I want to create a parser string. This is the code. That's how it works. But anyway, I'm asking you how it works, Nimrod. What does it do, the parser string?
If it's empty, it returns success. Otherwise, it checks. Checks character by character.
You can see how it works here.
Yeah, it checks character by character and then see if it's the same as the input.
So we create a new parser with a string. The parser here holds this string, and it checks if the input string has prefix, okay, which is the string. It returns it. Otherwise, it fails. Sorry, I'm looking at this code. I don't understand why return here success. I just don't remember what was the point, but I'm not sure.
Because if it's empty, you can empty prefix is always true. Empty prefix is always true.
Yeah, I have to handle this special case because it doesn't work. But I don't remember if I should return success or failure. But you know, it's kind of requirement. That's what product manager wants. If product manager wants success. Okay. Well, and now a little more complicated example, just a little more. I want to write a parser. Okay, I mean list here. Sorry.
Parser was incorrect.
Yeah. Okay, and I want to parse strings in this format. I mean, I want to parse lists of natural numbers, and this is the notation. just comma separated natural numbers in brackets. That's what.
This is the format of the string you're parsing?
Yeah. Yeah. That's the string. Okay, I should probably fix it. Okay, but I'm here to explain. Well, and in order to do that, we should make some preparations. By the way, you see that every parser, every snippet of code is just 2 or 3 lines. So it should be very simple, yeah? So it's just 2 lines each function. So this is combinator. Plus is a combinator which applies 2 parsers and just merge the results of the parsers. Okay, I'll say it a little bit differently. Plus is a parser combinator. What if I say combinator? I mean a function which receives parsers as arguments and returns and yields a new parser. So plus takes 2 parsers as its arguments and yields a new parser which works, okay, this way. Again, the interesting part is here. So this is the parsing function. It just applies, this function just applies the first parser and the second parser and merges the results. Okay, just a combinator. Now I want to define combinators that apply a given parser 0 or more times or 1 or more times and return a parser which yields a list of A. So I have one parser of A, and I want to build a new parser which returns a list of A. Okay. It just applies this parser P again and again and again with the flat map. Okay, how it works? It's actually plus. This for comprehension statement is a new parser. Okay, so how it works? It applies this and applies and recursively calls this to the rest. Okay, and this is actually the exit condition. And many1 returns the parser. Okay, and this, if you know this syntax, is it constructs a list. You know, maybe I have an example. So, wow, I don't have. Do you want me to see the example for many? Well, let's try it. I have a lot of time, by the way. Yeah, it's 12 and 15 minutes, and I have something like, I don't know. I have a lot of time. Just a second. You know. Sorry, guys. Sorry. Okay, sure. Well, let's do it this way. Okay. And okay. You don't see it? No. No? How to increase it? Plus, Control plus?
Command plus?
Command plus? No. It works?
Yeah.
Okay. Okay. Okay, so that's how I prepare this presentation, by the way. This
Hold on, wait. Hold.
Okay, just a second. Well, so this is my source in VI, and this is the REPL. Let's try to do some exercise with many. Let's see if it works. Well, so let's say I have a parser this parser A, which consumes character A, and let's say I have a parser many A, one or more A's, which is actually this. Okay, that's how I construct the parser of many A's. And now let's try it. Okay, that's how it works. It returns here, okay, list of results, and each result is each result is a list of A's. Okay, it tries to recognize many A's here. So, but 1A, 2A's, 3A's, all these substrings should be recognized. So this is the result. Okay.
So parsing a number just use the digit? To parse a number?
Yeah. Mm-hmm. I'll construct a number natural parser with digit. Yeah. And excuse me. What's it? Okay. Okay. And natural parser. Okay. That's how it works. This is the parsing. So this is only the parser. Okay. So this parser returns many results, and this is actually evaluation part. Do you understand how the evaluation works? No.
Close.
Okay.
Converting these strings.
Just a second. I want to do it, in turn. Aviran again. Sorry, I'm doing this way. Do you understand how it works, the evaluation? No. Itai? No. Anatoly? Alex? Could you explain how it works, the evaluation part? You had okay. What is the type of the digits? A list.
Okay. If I didn't know what it should do, then I would have no idea what it does. But given that I know, I can vaguely understand what it's doing.
Okay.
The solid left there is taking all the digits and converting them into a number.
Yeah. Yeah. So okay.
Or minus 0 is converting into a digit. Other than that,
yeah.
Beautifully.
Okay. Okay. Simple question. What's the type of the digit?
Probably. It's a list of
No, it's a parser. Excuse me. No, it's sorry. No. This is the parser. And the type of digits, it's type of result. This parser, the result type of this parser is string.
So we take a string of
digits and we convert it into
to number.
a number.
Yes. So we map every character, every digit actually, to integer in this way.
And
then you fall left. You turn it into
Horner scheme. How is it called? To evaluate polynomials. Horner scheme. Okay. And that's how it works. So we have a parser, natural, which parses a string. You know, we can.
This is the success string, empty string that you had. In the 1, 2, 3, you can see the empty string from the success.
No. This is the rest of the string. No, I don't have an empty string. No. Okay, do you want me to try it as a natural parser? Okay, let's go. Okay, finally, we'll be able to return and play with the REPL after that. Okay, finally, I've told that a little bit sick, so I want to make it short, this session, but I want to present this real parser. So this parser, you remember that we wanted to parse a string in this format. And this is the parser. Okay, this parser returns a list of ints. This is the result type. Okay, this parser, it returns a list of pairs, but the result type is a list of int. And we do it with for comprehension. So first, we try to recognize the open bracket. Then we try to recognize numbers. Then we try to recognize many comma-separated numbers, and this is actually comma-separated number. No, it's not recursive. It's naturals.
natural.
Yeah, it's not recursive. No recursion. Very simple.
So why is there
the regular expression?
Huh? Yeah, I understand. You can, okay, I understand. You can say, I thought about it. You can say it's a regular language. You can parse it with regular expression. So why do you bother building all this stuff? I understand. I thought about some non-regular. By the way, I thought about some non-regular language, like matched brackets. And I have this example, but I chose this one.
It's a declarative automat that takes the string and starts some stuff to it, and it's very good.
Okay, so that's how it looks. That's how it works.
Excuse me, why did you have the first natural here? Why not the only? Why not remove that natural?
Okay, maybe I can do it differently. I don't know, but I chose it this way.
Oh, the comma.
Yes, I want to. Yes, I want to separate. Okay, I understand. This is a parser to recognize a comma and a natural. Well, just a few words in the end.
It's the best way to expression ever.
What was it? That it was an example of monad. Just another example of monad, like option, like list, like either left and either right. It was just another example of monad. Before that, you can think that monad is like a container. You know, option is a container and list is a container, but monad is not just a container. It's more, it's an abstraction of higher level. So this parser is not a container, but a monad. The question is it the only way of building parsers. Okay, no. Is it the best way of building parsers? No. But it was.
It's a cool way.
It's a cool way to build parsers. By the way, if you want, there is more a cooler way to build parsers built on top of applicative functors. If you want to see it, I can prepare a session. And just to remind you that that's not just an exercise, an academic exercise, but it has some pragmatic value. That's how the standard parser library of Scala is built. So in Haskell we have parsec library built on top of it, and in Scala they just ported this parsec library into Scala, and it actually works this way, but that's probably not the best way to build parsers, but as an example it's cool. That's all. If you want, we can play with REPL, or I don't know, if you want. If somebody wants. Thank you.